Dr. FEMINATH. Today I am going to explain to you a technique which we have developed, that is no HANDFILE technique, which makes endodontics much easier. We have applied for patency and the patency for this technique is pending. And meanwhile, I'll just explain to you how this technique which we have developed makes endodontics much easier, much predictable and much safer. The biggest advantage of these files is that the chances of no ledge, there are no chances of lead formation, and it just makes endodontics much faster and much easier. So now let's go to the technique.
So in the conventional technique, after the access opening is made, we use smaller hand files, stainless steel hand files, to establish a patency from the coronal portion till the apex of the canal. When we move the hand files from the coronal orifice till the apex, you will encounter resistance. Sometimes the resistance will go off, then again a resistance will come in. So there are multiple places where the files are subjected to resistance, the torsional resistance. So the chances of fracture is also there when it is subjected to resistance on its path. More than that, when you have a curvature, when you confront along with the root canal, chances are there that the files, which is made up of stainless steel, can get blocked in the curvature and can result in ledge, which can result in ultimate failure of the root canal treatment. So in the case of no HANDFILE technique, what we use is, normally what we use is 30 size 6% to enlarge the coronal orifice without any hand files, and it will go down till the resistance is met. We do not go beyond the resistance. After that is done, then you shift to a smaller size, for example 25 size 4% tapered rotary niti, and then go till the next resistance is met. So what happens is, if you have a curvature, by the time you reach the curvature, the coronal portion of the curvature is actually enlarged, making the path to beyond the curvature much more easier. So chances of ledge formation is minimal, less. Now since we are doing entirely a crown down technique, what happens is, the coronal portion, the debris in the coronal portion is taken out. Then slowly when you go down, almost all the debris which was there will be taken out. So the amount of debris which will be extruded beyond the apex is very minimal, resulting in less amount of endodontic flare-up. And as I have said, we use the larger size 30 size 6% rotary files. Sometimes that itself will reach till the apex. So number of files which is used is very less, and 60 to 70% of the cases can be completed in two files itself. That is 30 size 6% and 25 size 4% will take you till the working length. So the effective time used to complete a root canal treatment will be very less. So these are the major advantages of no HANDFILE technique. The disadvantage of no HANDFILE technique is that it cannot be used in calcified canals, because the rotary files does not come lesser than 0.13 millimeter in diameter. Not only that, if you have a calcified canals, you will have to use C+ files to negotiate the canal, and that will not be done with no HANDFILE technique. And coming on to the technique, arbitrary working length, approximate working length is measured by using RVG from the occlusal table till the apex by connecting any curves. So after the length is measured, 1 to 2 millimeters is reduced depending upon the curvature present in the canal to compensate for any error. So that is, if it is highly curved, like say for example by 45 degree, you have to reduce it by 2 millimeter. If it is almost a straight canal, you can reduce the arbitrary length which has been measured -1. So for example, if it is 18.3 millimeter from the occlusal table to the apex. Then if you have a severe curvature, you can keep it as 16.3, and if it is a straight canal, you can keep it as 17.3. This is the length which I have taken from the occlusal table to the apex of the tooth, that is around 18.2 millimeter. Now I will reduce 1 to 1.5 millimeter to determine as a working length, because to eradicate any error in the working length from the RVG, and for the straightening of curvature, that is one thing. Now I will take up 30 size 6% file and set the working length as 17.2, and then I will just passively insert it into the canal. This now, and then take an X-ray. I am just putting it passively into the canal and taking an X-ray, because for you to understand, normally I don't do that, just to passively place it into the canal without any rotation, and then expose an X-ray, so that you can understand it, how much it goes forward without any rotation. After I will just show you the X-ray, and after that I will start rotating it without any apical pressure. Without any apical pressure, I will be rotating it forward. So then I will find the resistance. Now this is the length. Now what I am going to do is 30 size 6%. I am going to rotate it forward. When I feel the resistance, I will just stop it. If you further try to push it forward, then there is a possibility of a ledge formation happening. You can see that now. I will just stop it and I will show you the X-ray of till where it has moved forward. After that, what I will be doing is I will change to a smaller size file. Now this is a X-ray of 30 size 6% till where it has moved forward. Now I will take 25 size 4% and again place it passively, and I will show you an X-ray till where it has gone without any rotation. After that, the same procedure will be done again, wherein I rotate it again. Now it has gone till there without any rotation. Now again I am going to rotate it. You can see that I am rotating it with the rotation, no pressure apically, passively. The rotation has to take it forward towards the apex. That is the key. Now see, it has been taken forward, and I will show you the X-ray. Now this has reached the working length. So that means to say that just by two files we have reached till the apex. All right. Now I am just taking it out. Now I am going to place a GP con in 20 size 4% into that area, and I will expose an X-ray. So you can see that it has gone till the apex. So this is the first X-ray, the second X-ray, and the third X-ray, fourth X-ray, and the fifth X-ray. You can see that the first X-ray, it is gone without any motion. The second X-ray after the motion with the first file. The third X-ray without any motion, without any rotation in the third X-ray. On the fourth X-ray, I have gone till the tip, and the fifth X-ray, it is the master cone. So you can see that this is the process. So by using this technique, you can use minimal number of files to reach till the apex. In the video, I have shown that we have reached the working length by using just two files. If it does not reach by using these two files, then you have to shift to 20 size 4%, and then if it doesn't happen, then reduce it to 17 size 4%, and then you can use 20 size 2%, and then 16 size 2% and 13 size 2%. Once we have reached the working length, you can always do a step back technique to enlarge the canal till the working length. Now, there are certain precautions to be taken when you follow this technique. Never ever apically force the files. Only a passive apical pressure, which usually has to be done by the rotation. That is, the rotation of the files has to take the file till where you meet the resistance. That is the first point, number one. Just by rotation alone, the files has to be taken till we meet the resistance. Once you meet the resistance, stop it and then take it out. If you continuously keep rotating in that area, what happens? Because of the rotation, there will be a step formation resulting in ledge. So these are the two things which you have to take care. Never rotate a file in the same position for a longer period of time. Immediately on resistance, take it out and then place the next smaller size file. This is the key for the success. This is what you should not be doing. Once you go apically and then resistance is felt, do not keep it rotating once the resistance is felt. If you keep rotating, what will happen is there will be a step formation and a ledge formation, and the subsequent files will not go further beyond that. So this is what you should not be doing in this technique. So coming on to the conclusion, basically the chances of instrument fracture is very less, because the chances of torsional and cyclic fatigue failure is not there, because you clear off all the coronal portion resistance as well as the curvature before you go into the apex. So the instrument is stressed very minimally, so the chances of fracture is very less. When using conventional technique, when you are using, as I have told you, glide path files, in small hand files, there can be sudden narrowing and unexpected curvatures which can result in unexpected fracture, which is not present in our technique. So the reason being, the coronal flaring reduces such incidents, and not using glide files enhances it. Since there is a step-by-step removal of the coronal interference while moving apically, it reduces multiple stresses at different length of the file. So the results are that there is immense amount of working time which is reduced. There is reduced working time. Chances of fracture is less, because you are removing all the resistance in the coronal portion before you move down, as well as the curvature is enlarged coronal to that, so that the curvature negotiation becomes easier, and the ledge formation is very minimal. And since all the debris from the coronal portion is removed prior to going to the apex, least amount of debris extrusion into the periapical region, so chances of less endodontic flare-up and less chance of post-operative discomfort. Thank you for watching this video. This file technique has been completely made for HANDFILE files. And if you have any enquiries, any doubts, you may please WhatsApp me in this number, or you can give me a call. Thank you so much. Till I come up with the next video, it's goodbye from me.